Hello everyone, my name's Ian Baldwin. I'm from the Information Lab in Ireland, and today's webinar is Rugby Ruckus, using data to predict the Six Nations. Who are the Information Lab? Hopefully most of you already know us. We're a consultancy and training partner for Ultrix and Tableau. We've been an Ultrix Premier partner, and we're a Tableau EMEA Partner of the Year 2018. So today we're looking at predicting the Six Nations. Six Nations is a rugby tournament between the four British nations, France and Ireland, France and Italy, and they all play each other in a round-robin match, and we want to predict each match who will win by how many points. For example, Ireland will win by 7, Wales will win by 10, or France will win by 3. We did predictions as well last year. Over 15 matches, we got 12 correct results in that we predicted the correct team would win. So if we said Ireland were going to win by 6 and they won by 4, we're taking that as a correct result, but we didn't get an exact score. And then out of those 12 matches, 2 of those were a correct score. So say we said Ireland to win by 8 and the result was on the nose, Ireland to win by 8. That's the correct score. So rugby is quite a high scoring game, and so it's going to be very difficult to predict exact scores. But 12 out of 15 results and 2 out of 15 correct scores we're quite happy with. Our big miss last year was we predicted England to win the Grand Slam. The Grand Slam in the Six Nations is when you win all 5 matches, and so you go the tournament undefeated. Actually, England only won 2 matches, I think, so we were wrong on 3 England matches, and actually they were all of the matches that we missed the result on. So perhaps something we missed structurally there. We thought England were favourites going into the tournament, but they only won 2 out of 5 games. The other 10 games in the tournament, we did get the correct result each time, but England we missed. Maybe after they lost the first game, confidence was knocked and they didn't recover from it. Maybe there was something else going into the tournament that we just hadn't picked up on. But overall, 12 out of 15 correct results. Last year we're quite happy with, and that's our benchmark this year to try and beat. So when you're predicting rugby results, where do you start with that? What data do you need as your inputs? Match results, like past match results, that's probably quite important. So historically how teams done. If you don't have that, you're really starting from scratch. Other variables we could have looked at, player data. Could we find information on how many points certain players have been scoring and are they available this year? Club results, say, do Scotland do better in the Six Nations when Scottish clubs do better in European club tournaments? Or do French teams do better when French clubs have done better in Europe? That's a possibility. Injury news. Is there a way we could bring in injury data into tournament predictions? So if Italy have 6 big injuries before the tournament, are they going to be adversely affected in a way that other variables wouldn't pick up? Another idea is weather. Do, say, Scotland play better in the rain? Do Italy play better in the heat? Could you take weather forecasts and try and link that to the outcome of a game? That's a possibility. Managerial records. So each country has a different manager who manages the side, helps in selection, picks all the tactics. Are there standout managers who are doing better than their contemporaries? Or are there particular managers who have been a better run that will adversely affect their team? So these are so many different variables you can think about going into a game before you've actually decided to pick out that data. Last year in our predictions, we used a model called a random forest model and did actually use a lot of these different variables into predicting our matches. But this year, I wanted to go for something simpler. We could have followed the same process and got the same data, but following the random forest model is a bit of a black box into how does it make its predictions. You kind of know which variables are important, but you don't necessarily know why those variables are important. And so we're sort of clouding our eyes a bit by chucking everything in it and taking a model and saying that's what we want to do. So this year I wanted to take a step back and make a model that you could more tangibly follow the results of each prediction and how things went on. So out of all these different things, I went just with match results. This data is available on ESPN's StatsGuru website. They have all international rugby matches going back to 1871 in their database. So you can see this very first game was between Scotland and England in Edinburgh in March 1871. And Scotland won that game 1-0 when there was a very different scoring system to the system there is now. And this table has every international result going up to the present day. So you can see at the bottom it says page 1 of 94, 200 results per page, 18,000 results total. So you can go through these pages one by one, and there's a table there that's ready. You can just copy and paste it into Excel. You don't need any advanced web scraping techniques. Like, they could help, but you could do this manual work in a quarter of an hour of just scrolling to the bottom, clicking next, copying a new page and going on. And then you've got all international rugby matches kind of there at your fingertips in a data set. Some of it did need a bit of cleaning, and we had to look up different locations to work out whether a team was home or away. So for instance, Wales versus Scotland was in Cardiff, and you know Cardiff is in Wales, but there was, in the data set, there wasn't something to say Wales was at home. So we had to kind of enrich the data set a little bit to say, if the team is Wales and the ground is Cardiff, they're at home. And then it's vice versa, Scotland are going to be away in that match. But otherwise, it's a lovely data set to work with. Very accessible. You can copy and paste it, and away you go. So now we've got our data. The next step was choosing our model. And we went for a model called ELO model, or ELO rating system. The ELO model is a model that works just looking at past results. It has pedigree across board games, sports, esports. So it was initially developed for doing player ratings in chess to see which grandmaster is the best. And then once that was developed in, I think, the 50s or 60s, it's kind of been taken up by more and more games, sports, and more recently, esports. So if you've ever been playing a game that has like an online ranking system, like FIFA or Rocketball, there's a good chance that there's some variation of the ELO model that's creating your player rating and that will match you against other opponents around the world of a similar rating. So you can tell it's scalable because you can get these online esports with hundreds of thousands, millions of players that all have some variation of this. And after a few games, it very quickly helps you find your level as a player. So you're not always playing against someone that's too much better than you, and you're not playing against someone that's a lot worse than you. So that's kind of its general usage nowadays. Some of the key aspects of the model that I like is it uses kind of all historical results. So we can feed in the data all the way back to 1871 and create like a definitive rugby ELO model. but more recent results do have a greater weight. So even though we're putting England versus Scotland in 1871 into the data set, because it's so far back in the data set, it will have minimal influence in what your actual score is now, whereas more recent results have more influence on your ratings. So you can backload it as far as you want, but it still gives more weight to more recent events. Next thing is it accounts for strength of opponent. So if you're England and you're playing against, I don't know, San Marino or Andorra or one of those kind of tiny countries, then because the model would know that England is so much better than those countries, pretty much by virtue of its size, it won't credit England much with a win because they're expected to win. So you can't game the system by playing weaker opponents because the system will reward you less for playing those weaker opponents. And on the flip side, if a small country like that had a big upset and beat one of these giants, they would be greatly rewarded by it because it wasn't a match they were expected to win. So they would see a much greater boost in their ratings for winning as the underdog than they would have lost if they had lost a match. And then finally, you can adjust the ELO model for home advantage. So you can kind of build in how much is the advantage of playing at home, because this happens across most sports that are played in front of a crowd, in front of an arena, that the home team in sport has an advantage. You see it in football, rugby, cricket, basketball, American football, studies over and over again, save for sports, there is a home advantage, whether it's just because the crowd cheering you on gives you a psychological advantage, whether it's because you're kind of more comfortable going up into the game because you always play at the stadium, you have the same routine. Maybe it's because the away team has travelled a lot and so they're tired when they get there. Maybe that affects the away team negatively. But generally speaking, sports have a home advantage and you can bake that into your ELO model. So England playing at home against Ireland will have a different prediction from England playing away against Ireland. So that's a bit of background. The model itself, each team has a rating. You can initialize them however you want. Generally, models start with giving teams a 1500 rating, and then over time, those go up and down. And then the thing that drives the prediction for a game is the ELO difference. So if a team has a 300-point advantage, like in this graphic here, Ireland has a 300-point rating advantage over Scotland, then the area of the chart represents the win percentage, and that makes Ireland it gives Ireland a 75 to 80% probability of winning this match. So Scotland still has that tail, but that's around 20-25% chance of winning a game, where they have a disadvantage of 300 points. The rating points are sort of arbitrary and you can change them on any scale. So it's only once you then go and back test them that you can bring meaning to these differences. And what does a 300 ELO difference mean in a model? And so it could actually be, in rugby, 300 ELO difference would have a 75 to 80% chance of a win. In another sport where, say, this bell curve could be a lot taller, that percentage could be even higher for a 300-point difference, or the bell curve could be a lot wider, and that would mean that 300-point advantage is worth less. It's just something that you have to do in refining your model to say, yes, these are the parameters that we're going with. So now we're going on to building the model in Alteryx. So hopefully most of you have come across Alteryx before. Maybe you've not used it, but you've heard of it. It's one of our tools of choice at the Information Lab. It's fantastic for advanced analytics. Some people call it the Swiss Army knife of analytics. You can create to pretty much any sort of data set, whether it's Excel, flat files, databases, whatever. And then at the other end, you can also write back out to any of those, or to a Tableau server, or to any other kind of visualization software. So Alteryx is our tool of choice. And I'll give you a quick run through of building the ELO model. So this is Alteryx. Hopefully you're familiar with its layout. If you're not, I'll try and explain what's going on as we do it. First of all, we had to go back through all the historical data and work out the parameters of the model. As I was saying, that bell curve could be of a different shape. And then once we had done that, we would actually then run it through this year's fixture. But before we could get to this point, we had to build a macro that could do these ratings out of the box. So within this Alteryx workflow, there's input of our data. So I had 2 tables of international results. I had to clean them a bit. And then kind of the magic happens in this blue square, in the ELO iterative macro. And this is a macro I had to build in Alteryx that performs a function, but now I've built it, I can put any data set and run kind of any ELO model through this macro. So this is the macro itself. It has 2 inputs and 2 outputs. On the left-hand side, one of our inputs is list of team names, ELO scores, and what is called a K factor. So the K factor is the key parameter that determines the width of the bell curve that we saw previously. So it doesn't directly affect that, but it affects the volatility of the model, which in turn will affect that. So we needed some initial ELO ratings, and then the other input is a list of results. So copy and pasted all of my previous match results. The key things were giving each match an individual ID. We had the data on 2 rows. So one match is split over 2 rows, 1 row per team. So the data structure is match 1 on this day, team England lost against Scotland and they're away. And then the second row is the inverse of that. So match 1 on that same day, team Scotland won against England and they were playing at home. So you need 1 row per team per match so that you can eventually update each individual team's ratings. So we'll pass this row through and update England's rating on the fact that they lost. And then we pass this row through on the fact that Scotland won. So that's that data structure for bringing in the results. And so this iterative macro is designed to go through matches one by one. So you can see match ID number 1, then match ID number 2, then match ID number 3, match ID number 4. So this match data is coming through in bulk, but we only want to operate on 1 match at a time. So in the first iteration of this macro, we want to operate on match 1. On the second iteration, we want to operate on match 2. On the third iteration, we want to operate on match 3. So even though the data is coming in bulk, we need to make sure that we're only getting 1 match at a time. So this is what this filter here is doing. It's making sure match ID equals the iteration number, and we're only keeping that match. So for iteration number 1, we keep match ID number 1. For iteration number 2, we keep match ID number 2, and so on until the data set is exhausted. Then we connect the ELO ratings to this data coming in. So row 1, we have England, Scotland in that very first match. But in our ELO ratings, we have initial scores for 160 different countries that played rugby. So even though we're only interested in the 6 nations for our eventual predictions, we can bring in all international results and have each of those ratings have an effect. So if France lose to Fiji in November, that means France's rating will still go down in our model. So we're still aware of recent results not directly involving 2 of these teams. So we have this full list of teams, and we just want to join on the ratings of each team and their opposition. So you can see team ELO score, or ELO score, and opposition ELO score coming in, and that's now joined to the data. So our data set is team Scotland and England, their respective ELO ratings. Because this was the very first iteration, we had to give them an initial rating, and so ELO ratings don't become effective until teams have played say 10 or 20 games. But you've got to start somewhere, right? And because the data goes back to 1870, it doesn't matter if we didn't have a correct hook on their ratings at that point in time. So start somewhere, give them both a rating of 2000, and then we'll let the model update as it comes through time. So there's several parts to calculating the expected win percentage and updating the scores. First of all, we wanted to adjust the difference. So as we were saying before on this slide, there's a team with, in this match, 300 points of difference. If they're playing home or away, that could change. So maybe in this game, Ireland are at home and the difference is 300. And if they're playing away, their kind of respective difference is only, say, 150. So, so although initially the difference between these teams is 0, because team ELO 2000, opposition ELO 2000, Scotland were playing at home, so we want to give them an advantage. And so as an adjusted ELO difference, we worked out that's actually 75 points. It's a little bit confusing in this mathematics because here we want to put in a minus number that says this team is more likely to win because of the way that the expected win percentage is calculated. So you can go to Wikipedia and search ELO rating system, and there is kind of the maths that goes in detail on calculating win percentages, but essentially the adjusted difference we want is this point here, and it's relative to the other team. So a minus score, counterintuitively, is better than a positive score. So that's why you see adjusted ELO difference minus 75 there. But then the next calculation, expected win percentage, Scotland at home gives an expected win percentage of 60%. Then the converse of that, England away, it's the same match. It's almost 40%, so 60.6% and 39.4%. That totals up to 100. So that was the expected win percentage going into a game. And then the model updates itself relative to that win percentage. So as Scotland had a expected win percentage of 60% and they won, their result is their rating is updated by a factor reflective of that win percentage. So they gained 7 points in this model going into a game with an expected win percentage of 60. If, say, their expected win percentage was 95% and they were playing against a much smaller nation, maybe they would have only gained 2 or 3 points for their ELO score. And conversely, if they'd been playing New Zealand and New Zealand were much better than them, they would have gained maybe 15 or so points. It depends on your expected win percentage, how much the new score changes. But this is the calculation that we use to do it. If you go into Wikipedia, essentially the new rating is an expression of the differences multiplied by a constant. I'm going to share the macro on the Ultrix gallery later. So if you want to get into the depths of the mathematics, you can unpick the tool yourself. And also I would recommend kind of further reading if you really want to get into these calculations. But you can see on the screen, there's kind of 3 steps. There's calculating the adjusted ELO difference, there's calculating the expected win percentage, and then there's calculating the new ELO score as a result of that actual match. So Scotland won, their rating went up. England lost, their rating went down. The last 2 points in this ELO macro that we built in Ultrix is firstly to output the new ratings so that we have kind of a historical record of how the ratings are changing over time. And then it's also updating the ratings for the next iteration of the macro. So in Ultrix, an iterative macro takes one of its outputs and sends it back to the beginning. So we join the new ratings back onto the original list with like a find and replace, and that gives us the new column of ELO scores. So you can see, whilst every other country is still initialized at 2000, Scotland and England have gone up and down respectively. We get to the end, get it into the same data format as the data is coming in, and then the ratings are passed through the next iteration. So this data comes back to the beginning. The macro will run again as an iterative macro, and then next time it will take match 2 and it will pass everything through the system. Then it will take match 3, pass everything through the system, continually updating this list of ratings until we get to essentially present day. So this is the inner workings of the macro. It's on the Ultrix public gallery. I'll share the link at the end, and you can dive into it yourselves and use it for yourselves for any other rating systems that you want to predict. But that's the core of it. So once we had that macro, we could run basically the entire history of rugby results. So I had 2 data files, one up to the end of 2017, and then that I had got last year, and then I had to update it with recent internationals as well. We passed it through the macro, and we had an output at the end of it that was a full list of ratings over time. And so we could visualize this in Tableau. So this is just a quick look at some of the top nations in international rugby over the last 20 years. So the Six Nations, the Tri-Nations, and then the British and Irish Lions are also in this data set. But we can actually go back and see this is how the ratings have fluctuated over time. So in the early 2000s, actually, Australia were top for a brief period, and then England were top for a brief period, and then we've had 20 years of New Zealand dominance. But these are just the major nations in international rugby. But as I was saying, because I have all international results, I can actually look at 161 different countries. So I can see this is Luxembourg's rating over time. This is Lithuania's rating over time. This is Paraguay's rating over time. So we initialize them at different levels because there is kind of an understanding of tiered rugby nations. So there's top tier, second tier, and then there's like rugby nations below that. So the Big Ten also do have an inherent advantage. So we started them at a score of 1,500, and then we started everyone else at 500, and then let their ratings fluctuate as they go. And so United States, maybe we initialized them slightly wrong because I put them as a 500 score at the start, and they've slowly creeped up to over 1,000. So the initialization can have an effect, but this was sort of a best judgment case of how do we want to bin each of the different nations into respective categories before we start the model rolling. But for major nations, this is what it looks like currently. I'll come back to kind of modern day. Actually, this also includes a couple of Six Nations results recently, but going into the tournament, Ireland were the best of the Six Nations. So this line at the top is New Zealand. They're not in the tournament because they're from the Southern Hemisphere rather than Europe. But that's kind of there as a context of New Zealand is still the best team in rugby. But out of the Six Nations, Ireland were top. Then there's England. Then there's Wales. Then it's Scotland and France. And actually Italy somewhere slightly further down as well. So Italy are there. So that's just visualizing the history of our rating system. And now we want to actually get into the step of predicting future results based on this rating system. And so putting results into a scatter plot where we have the eventual points difference versus the adjusted ELO difference, we get this graph. There's a fair amount of noise. Like you can see this team went into a match with a 200 point advantage and then a 200 ELO point advantage and then lost by 50 odd points. So it's not a guaranteed predictor, but nothing is an exact predictor. But this is the relationship that we got from putting in a line of best fit. And it says your eventual points difference in a match is roughly 0.05 times your adjusted ELO difference. So if you multiply that up, that's saying an adjusted ELO difference of 20 is worth 1 point in a match. An adjusted ELO difference of 200 would be worth plus 10. So this is where we're then turning the rating system into a predictor by taking this correlation of past results with the rating difference and with the eventual points difference. So that's kind of a quick visualization of the ELO ratings and how they compare to results. And so now we're in the business of predicting matches. And so this is a workflow very much like the previous workflow, but now we're only interested in these 30 matches between 15 matches between Six Nations. So this is a data set I've been keeping up to date so I can rerun my predictions with more information. So I'll show you our predictions at the start of the Six Nations, and then we'll also look at how they've slowly changed over time as more results are being fed into it. And then we also need the ELO scores and the ELO ratings going into the tournament. So at the start of February, this was each team's respective ELO rating. And then, as before, we passed it through the ELO iterative macro so passing it through the ELO iterative macro got us win percentages and ELO differences, which you can see here. But then you need to multiply that by the correlation coefficient to actually turn that into a prediction. So that's our predictions. That's how we ran the predictions. So let's kind of go back and look how we've been going on for this year's tournament. So results so far. These have been our predictions for the first 3 weeks. You can see down the right-hand side whether we got it correct or not. And so far this tournament, we've got 7 correct and 2 wrong. So in week 1, we had Ireland to beat England by 7. They actually lost by 12. And then recently we had Scotland to win in a game by 3. I think it was against France, and they actually lost by 17. But the other 7 results, we've got the correct team winning. And in one match so far, we've got a correct score. So we predicted before the tournament Ireland to win by 9, and then we got that prediction on the nose. So far we're kind of on track with our predictions from last year. So last year we got 12 out of 15 results and 2 exact scores. So we're sort of on track to meet that. Whether we'll just fall short, meet it, or beat it, we'll see over the next kind of 10 days. So this brings us on to predictions to this weekend. So we fed in all international results, including the most recent ones, and these are our results this weekend. We have Wales to win away at Scotland by 6. We have England to win versus Italy by 30 points, so that's quite a large margin. And then we have Ireland to win at home by 21 points against France, which again is quite a big margin in rugby. That's about 3 tries. And so I guess you'll also see bookmakers kind of predicting similar things here. Like, these are generally accepted. These teams are the favourites, especially the England versus Italy game. I don't think really anyone's expecting an upset there. But next weekend is the final weekend, and that's where this tournament gets really interesting, because there's a match between Ireland and Wales at the Millennium Stadium, and that could well be the deciding match for the tournament. So if Ireland win it, they might be champions, and if Wales win it, they might be champions if they both win this weekend as expected. So that's kind of the crunch match to see out the tournament that will decide the ultimate champion. And it's going to be a very close game, or at least we predict it to be a very close game. Before the tournament, we had Ireland as the better team, and we had them to win by 2 points. So this middle match here, Wales versus Ireland, we're expecting it to be close and Ireland to win by 2. But this was our pre-tournament predictions looking 5 games ahead. As we've been feeding the newer data into the system, Wales have done well winning all their games, and Ireland slipped up against England, which hurt their ratings slightly. So now we're actually predicting Wales to win that game by 1. So as you can see, really close game, could go either way. Before the tournament, we thought Ireland were going to win it. Now our model is erring on the side of caution and saying we think Wales are going to win this by 1. And if they do follow that result, and also win this weekend as expected versus Scotland, then Wales will run out as the Six Nations champions. So thank you everyone for joining me on your lunchtime to watch this video. I really recommend checking out the ELO rating system in more detail, going through Wikipedia articles and such to get a better understanding of the maths. I didn't want to go into that in so much detail today on a Friday lunchtime webinar. But you can also download our ELO macro here. So follow this link, which is tool.bi/ELO ratings. This will take you to the Ultrix Analytics gallery, and you can download the macro, inspect it for yourself, have a play around, and run it on your own tournament data. Maybe you want to apply it to football, to cricket, to a board game you've been playing with your mates. Yeah, any sort of competitive environment, the ELO rating system works really well for tracking player skill and team skill. So follow this link, tool.bi/ELO ratings to download the macro and get started. If you don't have Ultrix already, then you'll need to download a free trial. Ultrix do offer 14-day free trials to get started with your analytics. Yeah, thank you everyone for watching. My name is Ian Baldwin from the Information Lab Ireland. Oh, got a question from Joe. Yeah. Just thanks. Okay. Thank you, everyone. Actually, Joe, any chance you could send the Ultrix workflow? So I can't send the individual workflow with all the results, passing through that. But as I said, the ELO ratings macro, if you follow this link, tool.bi/ELO ratings, will take you to the Ultrix gallery where you can download the macro. So if you collect your own data and pass it through, then you'll absolutely be able to play around with that. Okay, thank you everyone.